Dear students, Namaskar. Today I am going to talk to you on fruit juice concentration. Fruit juice concentrates are today considered as semi-finished products suitable for production of respective fruit juices, fruit juice beverages, jams and jellies, and also in the preparation of fruit juice powders. Concentration of liquid foods is a very important unit operation in food engineering. Consequently, removal of water from fruit juices offer the advantages of reduction in weight, volume and cost of packaging, storage and transportation, besides ensuring microbial stability. The composition of fruit juices reveals that they contain water as the major component up to about 75 to 95%. Obviously, removing this water partially either by concentration or almost completely either by dehydration will have several advantages. This episode deals with the advantages and disadvantages of concentration process, evaporative concentration, freeze concentration, membrane separation process, comparative evaluation and packaging and storage. Advantages: economy in packaging, storage and transportation. It is obvious that by reducing the volume of the fruit juices by concentration, these requirements will be almost proportionately reduced. Convenience: fruit juice concentrates are today very important semi-finished products which can be conveniently used for producing a number of products like beverages, fruit juice powders, jams and jellies, etc. The convenience comes from the reduced volume. Economic utilization. Economic utilization of fruits during glut season ensures price stability and better microbial stability. By concentrating fruit juices, excess fruits during glut season can be preserved and stored conveniently in a small volume. This will prevent spoilage losses in fruits and price fall leading to distressed sale. All this means better returns to the farmers. Better microbial stability. Highly concentrated fruit juices have better microbial stability. This is largely dependent on the low pH and low water activity. Microbial cell membrane behaves like a semi-permeable membrane. Water from microbial cells permeates to the concentrated solution, thereby shrinking of the cells. Problems or disadvantages in the concentration of fruit juices. Cost of concentration. Energy and other utilities, capital cost, maintenance and labor constitute cost of concentration. Cost of concentration is largely dependent on the method of concentration. The method available for concentration can be grouped under three major heads. Number one is the evaporative concentration, number two is the freeze concentration, and number three is the reverse osmosis or a membrane process. Whichever method is followed, some energy input is required for water removal. In practice, about 1.2 kg steam is required for evaporating 1 kg of water from the juice. We will see that this requirement can be reduced by multi-effect evaporation. Nutrient loss. Among the nutrients in the fruit juices, ascorbic acid is the most important, which is subjected to losses depending again upon the method of concentration. Beta carotene, which is the precursor of vitamin A, though is reasonably stable under the modern concentration procedures, can also be destroyed to some extent. Essential amino acids are also destroyed to a varying extent. Aroma loss. Fruit aroma is the major contributing factor for fruit quality. Aroma loss is one of the most important disadvantages in concentration of fruit juices. This again is dependent on the method of concentration. Evaporative concentration resulting in a maximum loss. Browning and off flavor. Browning of fruit juice concentrates can take place during concentration, particularly in evaporative concentration and also during storage of the concentrates. Browning reactions or non-enzymatic browning reactions are of different types. They can be due to reactions between reducing sugars and free amino acids, generally termed as Maillard reactions. Browning can also be due to degradation and polymerization of ascorbic acid or polymerization of polyphenols. As in most chemical reactions, rate of browning reactions are proportional to the concentration of the reactant. Therefore, rate of browning is faster in fruit juice concentrates than in single strength juice. Browning reactions, in addition to imparting undesirable color to the product, can also cause off flavor development because some of the products of browning reactions are volatile compounds. Since nutrients like ascorbic acid and amino acids are also involved in browning reactions, it may be said that the browning can also impair nutritional quality of the product. Cloud loss and gel formation. Cloud or turbidity in citrus juice is the desirable characteristics. Cloud is responsible for most of the color and flavor associated with citrus juices. The cloud is a heterogeneous mixture of cellular materials and emulsioids held in suspension by pectin. For example, it contains 25% lipids, 34% protein and 32% pectin. Retention of cloud in citrus juice and concentrates is very important. The pressure applied in juice extraction largely determines the content and dimensions of the cloud particle. Large particles settle down on standing the juice. The particles that remain in suspension after centrifugation for 10 minutes at 360 G is defined as a cloud. The cloud or turbidity can be quantified by measuring the transmission of light radiation at 660 nanometers in a calorimeter or spectrophotometer. Cloud loss is usually attributed to be due to the activity of pectic enzymes. Pectin methylestrase converts pectin to low methoxyl pectin, which gets precipitated as insoluble pectide by combining with calcium or magnesium ions. On precipitation, it carries cloud particles along with it. Cause for cloud loss in lemon juice prepared from concentrate is reported to be due to the reduction in water activity below the critical level necessary for maintaining pectin in the solution. High acidity in concentrates can also cause pectin degradation and cloud loss. Pasteurization is the most convenient way to stabilize cloud. Any delay in pasteurization before concentration, therefore, can be a cause for cloud loss. The aim of technological developments in fruit juice concentration is to offset the disadvantages in favor of advantages. We have already seen that there are 3 methods available for fruit juice concentration. Among them, evaporative concentration is by far the most common method followed. Obviously, there are some advantages in this method of concentration over the other 2 methods. Evaporative concentration. Evaporation is considered to be the best developed and most widely used method. In this method of concentration, water from fruit juices is removed by boiling. For this purpose, different types of evaporators with the different shapes, designs and the way of operation are in use. Fruit juice concentration is commonly carried out in a table evaporators, plate evaporators, centrifugal evaporators, agitated film and wiped film evaporators. It is needless to say that today all evaporators used for concentration of fruit juices operate at low pressure, that is at low temperature. The evaporators used in food industry are plenty. In principle, every evaporator plant consists of 3 main parts, namely heat exchanger, vapor liquid separator and a condenser. In addition, evaporation plants include vacuum and feed pumps as well as metering and control devices. The major differences in the design of various types of evaporator is the heat exchanger. Accordingly, there are calandria type evaporator, plate type, mechanically agitated type, centrifugal type. These evaporators can be classified as low temperature evaporators, mean temperature evaporators, and high temperature evaporators. Low temperature evaporators operate at 10 to 35 degrees centigrade. They make use of refrigerant as heating and cooling agent. Though these type of evaporators cause very less heat damage to the product, there are many technical problems that make them not economical. Mean temperature evaporators. Most of the multi-effect evaporators belong to this category, in which the maximum temperature is 70 to 80 degrees Celsius in the first stage and 40 to 45 degrees centigrade in the last stage. Steam is used usually at 2.5 atmosphere and cooling water at 15 degrees centigrade. Examples are double effect forced circulation evaporator designed by CFTRI, rising and falling film evaporator of alpha level, Vigent Unipectin, Stokes from Denmark, Webb from GDR, and Kovacs from Hungary. High temperature short time evaporators. The type of evaporators are based on high temperature short time principle, according to which though water can be brought to boiling in a very short time at a high temperature, heat damage to the product is less. These type of evaporators usually operate as a maximum temperature of 98 degrees centigrade, that is in the first effect, and 40 to 45 degrees centigrade in the last effect. Examples of these type of evaporators are Unipectin's horizontal evaporator, which is 2 to 3 effect, and TEST, that is thermally accelerated short time evaporator of Gulf Company, USA. Plate type evaporators. These type of evaporators are made almost exclusively by APV company, although Weissmitz of West Germany are also producing in a small scale. The heat exchanger is made up of set of corrugated rectangular stainless steel plates, each separated by special rubber gaskets. Advantages of plate evaporators are mainly their low headroom, possibility of increasing or decreasing the heating surface by increasing or decreasing the number of plates, and hence evaporation capacity and easy cleaning. They have high heat transfer coefficients. They can be falling film or rising and falling film type. Prime cost are low. Mechanically agitated evaporator. It consists of large tube which is heated by a steam. Inside the tube there is a rotor whose baffle plates move along the surface of the tube. Depending on whether the baffles touch the tube surface or have a very small clearance, they are classified as scrape surface or thin film evaporators. For scrape surface heat exchanger, the edges of the baffles are fitted with materials like Teflon. By rotation of the rotor along the baffles at a high speeds, the juice is distributed evenly on the whole heating surface by turbulence with scraping. New surfaces are continuously created, which means less heat damage and higher heat transfer coefficients. These type of evaporators are suitable for concentrates of high viscosity up to about 20,000 centipoise. Centrifugal evaporators. They make use of centrifugal force to set the liquid to be concentrated into motion, whereby the liquid is evenly distributed as a thin film over the heating surface. The heating surface are steam heated double walled conical dishes rotating on a shaft. All these evaporators using steam as a heating medium and water at about 15 degrees centigrade for cooling require about 1.2 kg and 18 to 22 kg respectively for evaporation and condensation of 1 kg of water from fruit juices respectively. This is not a very economical proposition. Technological developments have made considerable progress to reduce these requirements. Multi-stage evaporation. Evaporation with multi-effects are characterized by the fact that they have two or more evaporator bodies which are connected in a way that the vapors escaping from one vapor liquid separator is fed into the heating section of the next stage to supply heat energy. It can be seen from the data in the table 1 that steam requirement is proportionately reduced with the number of effects. Similarly, cooling water requirement is also reduced because vapors from only the last effect is to be condensed. In practice, reduction of steam and cooling water are, the table shows that number of effects, a steam requirement and cooling water requirement. In the first effect evaporator, the steam requirement is 1.1 kg and the cooling water requirement is 18 kg, whereas in number 2 effect evaporator, the steam requirement is 0.65 kg and cooling water requirement is 10 kg. So on, fourth effect evaporator requires steam to the extent of 0.35 kg and cooling water about 5 kg. Even though steam and cooling water requirements in multi-effect evaporators reduce proportional to the number of effects, prime cost and operating cost increase proportional to the number of effects. Based on these contradicting factors, it has been found that about 4 effect evaporator is the most cost effective. Selection of evaporators. With so many types of evaporators at the disposal, proper selection of evaporator for a specific purpose is very important. To accomplish this, one has to take into consideration various aspects. Among the factors to be considered, the physical and chemical properties of the feed and the concentrate are very important. Cost of evaporator is equally important because that will reflect on the final product cost. Viscosity. The rheological properties of the feed and concentrate play a very important role in concentration process. The resistance to flow offered by liquid against the direction of the flow is termed as viscosity. Rheological properties and evaporation rate. Rheological properties of fruit juices have a significant effect on evaporation rate. The rheological parameters have been used for the design of the evaporation equipment. One of the criteria for the proper choice of the most suitable evaporator for the concentration of given fruit juice is a maximum value of fruit juice viscosity that can be handled in the different types of evaporator. Different types of evaporators have limits for maximum product viscosity. Table 2 indicates the maximum viscosity and concentration limits for concentration process. For example, in a crepe surface evaporator, the maximum viscosity of the product which can be obtained is 40,000 CPS, whereas a centrifugal film evaporator, the maximum viscosity of the product obtained can be 20,000 CPS, whereas plate evaporator, the maximum viscosity obtained is 400. In falling film evaporator, it is 200 CPS, rising film evaporator, it is 100 CPS, freeze concentration 200 CPS, and in reverse osmosis, the maximum viscosity which can be obtained is 50 centipoise. Fouling. Evaporator surface fouling results from the destruction of some heat sensitive compounds. It is the major problem in fruit juice concentration because it reduces heat conduction into fluid through heating surfaces, which in turn affects the rate of heat transfer and finally impairs product quality. Many operating variables, notably the temperature of the heating surface and to different degree factors like flow direction, flow rate, amount of vapors in the fluid and boiling or warming of fruit juices on the heat transfer surface are known to affect fouling rate. Heat sensitivity. Heat sensitivity is important in selecting an evaporator since it affects the quality of the concentrate. Changes in quality due to thermal degradation are dependent on process temperature, residence time in the evaporator and the nature of the product. Even though low temperature evaporators can cause less damage, high temperature short time evaporators concept has been successfully used in evaporating heat sensitive juices. Residence time of different types of evaporators vary considerably as determined by methylene blue techniques. The residence time of different evaporators is given in table below. In a recirculation type of evaporators such as forced circulation or falling film evaporation, the residence time is to the order of 40 minutes. In a natural rising type of evaporator, the residence time is about 23 minutes. In a single pass evaporators like mechanically agitated, the residence time is 1.80 minute. In a tubular film evaporator, which can be either rising or falling film type, the residence time is 0.90 minutes. In the plate type evaporator, both rising and falling film type, the residence time is 0.33 minutes, and in a centrifugal evaporator, the residence time is 0.11 minutes. Fruit juices like orange and passion fruit juice are highly heat sensitive and hence have to be concentrated in evaporators having low residence time and temperature or high temperature short time combining effect. Energy and cooling water consumption. Steam and cooling water consumption are the two major factors which determine the operating cost. Their cost can be reduced in a multiple effect evaporator. Steam consumption can be further reduced by vapor compression, even though multi-stage evaporation almost proportionately reduces steam consumption. The optimum stages are limited by high construction and operating cost. Freeze concentration. Freeze concentration involves partial freezing of the product and removal of the pure ice crystals, thus leaving behind all the non-aqueous constituents in the concentrated phase. The process is particularly suited for concentration of liquid foods like fruit juices containing volatile aroma. Present status of freeze concentration. Freeze concentration of fruit juices has claimed many advantages. Thermal damage to the product and aroma loss are minimum in this process. Energy needed to freeze a unit of water is only about that of vaporization. Energy can also be saved because the concentrate obtained in freeze concentration can be directly frozen before storage. It is further claimed that multi-stage freeze concentration process reduce energy consumption up to about 37 to 47% and operating cost up to about 50 to 70%. A major problem which still remains to be solved is that the final degree of concentration that could be achieved by freezing is much lower, only up to about 50 to 55% weight by weight basis than by evaporative process. Membrane separation process. Concentration by evaporation and freeze concentration involves phase change which make them energy intensive. Membrane concentration process do not involve phase change. The application of membrane separation process for concentration of liquid foods is of recent origin. Many advantages such as low operating temperature, selective dewatering and low energy consumption are claimed in favor of membrane concentration process. Osmosis and reverse osmosis. Concentration of fruit juices by direct osmosis has found very limited commercial applications. Reverse osmosis is finding increasing applications to concentration of fruit juices. Concentration of apple and orange juices by reverse osmosis has been carried out. Pre-concentration of tomato juice by reverse osmosis from 5 to 8 to 8.5 degree Brix prior to tomato paste manufacture was found to improve flavor and reduction in processing cost. Membranes used for ultrafiltration. Cellulose nitrate and acetate membranes were the earliest to be used for ultrafiltration and reverse osmosis. Since 1975, many types of membranes having different chemical composition and functional properties have been developed. They include polyamides, polybenzymetazole, sulfonated dimethyl polyphenylene, etc. Comparative evaluation. Three types of concentration, which is evaporative concentration, freeze concentration and membrane concentrations, have been applied to the concentration of fruit juices. The most challenging task before the processor is to choose the best process for a particular product. The economics of important concentration process such as evaporation with aroma recovery, freeze concentration and reverse osmosis has been carried out. Aroma volatiles are almost lost completely in the evaporative concentration and partly in reverse osmosis, depending on the molecular size of the aroma constituents. These aromas could be recovered at least partly or either by separating them from vapors produced in the evaporator or they permeate during reverse osmosis, which can be subsequently concentrated in the distillation column. In freeze concentration, aroma loss is minimum, but loss of solids is possible due to flocculation, crystallization and insufficient separation. The final concentration that can be achieved in the process affects the microbial stability of the product, the packaging, storage and transport cost. The maximum concentration that can be obtained is primarily dependent on the viscosity at the maximum admissible process temperature. Concentration cost. They include labor, capital, maintenance, utilities, non-selective product loss and other cost aspects. Labor cost vary depending on the degree of automation and the capacity of the process unit. Capital cost is directly proportional to the installed cost of the concentration equipment, including cost of spares and auxiliary equipments. Cost of utilities. The main utilities are energy and water. Energy consumption is usually expressed in steam equivalents. Cost of non-selective product loss. Substantial quantities of product may be lost during concentration. In evaporation, about 0.1% of the feed may be lost with the condensate due to entrainment. In membrane processes, product loss occurs because of the pinholes in the membrane, and in freeze concentration, solids can be lost along with the separated dyes, though in a new freeze concentration process, the loss is below 100 ppm. Packaging and storage. Drum filling. The most common method used for packaging of fruit juice concentrate is into large metal drums lined with heavy industrial plastic bags, usually double. The cooled or chilled product is filled, weighed, the bags sealed and the drum lid fastened. The filled drum is then held in the cold store. Container filling, that is aseptic. The method similar to above can be employed for filling concentrate into containers aseptically. The treated product from the pasteurizing plant passes through the aseptic filling machine, where the pre-sterilized bag is filled and sealed under aseptic conditions. Canning. Cans of large capacity are used. The process employs a volumetric can filler to receive the heated product, sterilizing and cooling the process. Fruit juice concentrates are semi-finished products, and concentration of fruit juices using conventional concentration technique can sometimes give rise to the product with poor quality. Under such circumstances, application of membrane technology will make the product more acceptable in the Indian market. Under these circumstances, the membrane technologies will make the product more acceptable in the international market. Thank you.